Hi everyone, thanks for coming to this session today. My name is Domen. I'm an Android engineer and have been for over 9 years now, and I'm currently working at Lyft. Today we'll be talking about foreground services, and before we start, I just want to ask how many of you have worked with foreground services? If you can raise your hands. Oh wow, that's a lot. Okay, and how many of you had to update an app that uses foreground services to target Android 14? Okay, perfect. There's not so many hands, which means that this talk is the right one, because soon there will be a requirement that any new app updates on the Play Store have to target Android 14. So if your app uses foreground services, you will need to make some of the changes. Cool. So to get started with the question, what is a foreground service? So we actually use foreground services daily, whether that's when we play some music and then leave the app, start the navigation, and then do other things like driving, or when we start activity tracking. All of these are notifications that are a result of foreground services. So a foreground service is for performing long-running operations that the user started in the app before leaving the app. And the difference between a foreground service and a background service is just that the foreground service is noticeable to the user through a status bar notification like the ones here. So the typical use cases are like music player app, navigation app, fitness app, or any other kind. So when should you choose a foreground service? Now, the question here is the answer is actually a bit more complicated, because first you have to ask yourself whether the task should continue while the app is in the background. If the answer is no, then you're okay just using asynchronous work like coroutines or RxJava, because it doesn't matter if the work gets canceled. If the work should continue in the background, then the next question is it okay if the task is deferred or interrupted? If it's okay, maybe because the work is not so important, then you should use task scheduling APIs like Work Manager. If the work should not be interrupted and has to start immediately, then you have to ask yourself, is this a short critical task? If it is, then you can use a foreground service of type short service. We'll cover this a bit more in depth later, but the most important thing is that this type of service can only run for about 3 minutes. If the work you have is critical and will take longer, you then need to check if there are alternative APIs available. If there are, then you should use those. For example, if your foreground service is dealing with location and you want to trigger some action when a user reaches a certain location, instead of that, you can use a geofence API. And then finally, if none of these other solutions work for you, then you can use a foreground service. Over the years, there have been a lot of changes to the foreground service that kind of makes them harder to use. So Android 9 brought a new permission that you had to declare in your manifest if you wanted to use foreground services. Android 10 introduced a foreground service type property that was mandatory for the location type service. We'll discuss the types a bit later, but for now, the Android 11 brought new types, camera and microphone, and some restrictions on when you can access the camera and microphone from a foreground service. Android 12 brought a great deal of restrictions on starting a foreground service from the background. Then Android 13 brought notification runtime permissions, and which means that when the user doesn't allow your app to publish notifications, you won't actually see a notification when you start the foreground service. And then Android 14 brought the biggest changes, which are that the foreground service type now becomes mandatory. Along with it, there are a few things that you also need to do that we'll cover later, and it introduced some new types. And then Android 15, which is going to release soon, brings a new foreground service type and additional restrictions on launching the foreground service from a background. So we talked about foreground service types, and basically what they are is they describe what kind of work the service does. The type needs to be declared in the manifest where you register your service, as well as in code when you start the service. It becomes mandatory with Android 14, and the reasoning is that Google wants to ensure the correct usage of foreground services and consistency across device manufacturers. Because historically, developers kind of abused foreground services, and also they behave differently on like Samsung, Huawei, and other devices. Each type has runtime prerequisites that need to be fulfilled before you can start a service, and a service can actually define multiple types. We'll see this later. So what are the types that are currently supported? It's camera, connected device, data sync, health, location, media playback, media projection, microphone, phone call, remote messaging, then media processing, which is new in Android 15, and 3 special ones, which are short service, special use, and system exempt. We won't go into details for each of these type. There's a nice documentation on the official developer site. We'll cover some of the more interesting ones. Okay, so how do you actually define a foreground service type? Well, in your manifest, when you declare a service, you now also need to include a property called foreground service type. And in here, you specify the type that the service represents. If your service implements multiple types, then you can separate them using the pipe operator. Additionally, as we said, Android 9 brought along a permission for foreground services that you had to declare in your manifest. And now with Android 14, additionally, you have to declare another permission for each specific type that your service implements. These permissions are automatically granted by the system, but you do need to declare them. Okay. One huge difference now is that when you target Android 14, either you release a new app or make an update, you will need to do a Play Console declaration. This is essentially a form that you have to fill out and that will be reviewed by the Play Console before your update goes live. And what you have to do is, for each foreground service type that you declare, you have to describe the app functionality that uses it, describe the user impact if the task were to be deferred or interrupted, basically why you cannot use Work Manager. You need to include a link to a demo video to show what the service actually does in your app, and then select a use case on why you're using a foreground service, basically making sure that it's a valid use case. There's a predefined list of use cases. If none works for you, then you can also just write a description and explain why you need it. Cool. So yeah, back to the service types. So for location, it can be used for long-running use cases that require location, like navigation apps. So for example, Google Maps. This was the first foreground service type that was introduced, and it was required already back in Android 10. We also mentioned that each type has a runtime prerequisites, meaning that before you can start a service of this type, you have to have location services enabled, and then either of the 2 location permissions granted. We also mentioned briefly some alternatives before. So if you need to do something when user reaches a specific location, then you should use the geofence API instead of the service. Another interesting type is the connected service one. It's used when you interact with an external device through Bluetooth, NFC, USB, or network connection. And it's interesting because it has very complicated runtime prerequisites. So at least one of the following three needs to be true, so you can actually start the service. So you need to declare one of the permissions in the manifest to access the network states and change them. You need to have one of the Bluetooth permissions granted by the user. Or if you're working with USB, you need to call this USB manager request permission somewhere. Additionally, if you don't want to deal with foreground services, you can use an alternative API like continuous data transfer with companion device manager, or if you're doing Bluetooth scanning, you can use Bluetooth scan APIs. Another one that was commonly used is data sync, which is for data transfer operations like uploading, backup, and so on. And this one is not officially deprecated, but the plan is to deprecate it in the future Android versions. So if you're using this one, it's recommended that you migrate. And you can migrate to a new API that was introduced with Android 15, which is called user-initiated data transfer. This API is really similar to a foreground service. It's for transfer jobs to a remote server that are started by the user. It shows also a notification, and it can run for longer periods of time. Additionally, you can use a work manager with an expedited work, or you can use a short service type if the work will take less than 3 minutes. Cool. And there are no runtime prerequisites. So the next one is media processing. This is a new one with Android 15, and it's meant to be used for time-consuming operations on media assets like converting media to different formats or transcoding. It has a time limit, so it can only run for 6 hours every 24 hours. And this applies to your whole app. So even if you were to declare like 3 foreground services with this type, it wouldn't sum up, but it would still be 6 hours. And if you go over this limit, you will get, the system will call on timeout in your service, and it will shut it down within the next few seconds. Cool. So now we get to the special ones. The first one is the short service. It's meant for quick, critical work that cannot be interrupted or postponed. So I don't know, for example, if you have a messaging app, you need to send a message. It's probably good that it's not interrupted, and this is a valid use case. So the timer will start when you actually start the foreground service, and it will stop when you stop the foreground service. If you exceed the 3-minute mark, the system will again call on timeout and shut down the service in the next few seconds. And there are no runtime prerequisites, so you don't need to do anything before you start the service. And also, it doesn't require play console justification, so meaning you don't have to fill out that form. If none of the types apply to you, then there's a special one called special use case that you can use. However, besides the Play Store form, you also have to perform or add another explanation inside the code on why you're using it. And how this works is, so when you declare your service, you also need to add a property called property special use foreground service subtype, and then provide an explanation on why you're using this type. This will then be used by the Google Play reviewers to determine if this is actually a valid use case. And if it's not, your app will be rejected. So yeah, foreground service notification. So we said before that each foreground service needs to display a notification, so it's visible to the user. This notification is typically visible for the duration of the whole service. It's a regular notification, so all of the rules apply. So you need to create notification channels, have runtime permissions from Android 13, and then also build the notification object. On Android 12 and newer, the system will actually wait for 10 seconds before it will show the notification. So if you start a foreground service and finish the work within 10 seconds, the user won't see the notification. On Android 13, the notification is actually dismissible. So like, if you remember in previous versions, you could not slide away some of the notifications. With Android 13, you can do that. And also because there's now a runtime permission for notifications, the user can reject it, in which case they won't see it. But in each case, the app will still show up in the task manager. So the user will still see that there is background work happening. So how do we actually create a foreground service? Well, the first way, which is the most traditional one, is to create a service and then call start foreground to elevate it to a foreground service. And then a new way is you can use Work Manager to define a long-running worker by also calling start foreground. And both of these both of these approaches are valid. So first we'll take a look at the service one. So what we do is we create a regular service by extending the service class. And then we override the onStart command function. In here, we then have to elevate our service to a foreground one, and we'll check this out later. But for now, we just have a regular regular background service. One thing to note is that services do not run on a background thread. They run on the main thread. So if you do any long-running work, you need to use a mechanism like coroutines or RxJava to move it to a background thread. Okay, so we have our service. Next, we have to declare it in the manifest. So here we declare it, and because we'll be using location for our service, we also need to define a foreground service type of location. Because we're using location, we also need runtime permissions, so we'll also declare the course and find location permissions. If you do not declare a foreground service type here in the manifest, you will get a missing foreground service type exception when you call start foreground. Next, we have to declare the foreground service permissions. So the first one is the general one, and then as we said, we also need to define the foreground service type specific ones. So in this case, the foreground service location. Both permissions are automatically granted. If you do not declare the general permission, you will get a security exception in your foreground service. If you forget to declare the type specific one, you will also get a security exception saying that starting a foreground service with type location on Android 14 requires all of the following permissions. Cool. Okay, so we've declared this. We can now create or kind of elevate our background service into a foreground one by calling start foreground. So the start foreground function accepts an object of service, a notification ID, notification object, and then a flag. So historically, this flag, you could pass in a 0, which is the foreground service type, but now from Android 14, you have to actually pass in the foreground service type. If your service implements multiple types, then you can pass them in using the OR operator. So basically same as in the manifest where you use the pipe operator. It's also possible to declare just a subset of types and call start foreground multiple types. So for example, if you have a service of types location and media playback, that plays some music when a user reaches, I don't know, a certain location. You could first start the foreground service as a location one, and then when you actually need to play the music, you again call start foreground with media playback type. Cool. Okay, so what to watch out for? If you still pass in 0 for the foreground service type flag, you will get an invalid foreground service type exception saying that starting a foreground service with type none has been prohibited on Android 14. If you pass in a type that's not declared in the manifest, so for example, if we only declare the location type and then passed in the media playback one, we would get an illegal argument exception saying that this type is not actually a subset of the ones that we declared in the manifest. So many errors. One thing is also that the start foreground function has to be called within 10 seconds of receiving the onStart command. If you do not call this within the 10 seconds, you will get a foreground service did not start in time exception. So make sure to not do any long work before calling this, but call this at the very beginning. So as we saw before, in start foreground, we also have to pass in a notification object. How do we create it? Well, it's a typical notification building code. So we create a notification channel and then use that channel ID to pass it into the notification builder. We specify the title, the description, the icon, and the intent that needs to happen when you click on the notification. Additionally, we have a set foreground service behavior function that accepts a few different flags. And what it does is basically determines when a notification will show up. So as we said, by default, starting with Android 12, the notification will show up only after 10 seconds. If we want to show it immediately, we can use the immediate flag. There's also the deferred flag, which right now behaves the same as the default one, so the notification is displayed after 10 seconds. Cool. Okay, so we have pretty much everything ready. We can now start our foreground service. We do that by creating a new intent, passing in the reference to our foreground service class, and then calling start foreground service. Okay, we do this, we click on a button, the foreground service should start. However, we get a crash. Why is that? Okay, let's look at the logs. So we received a security exception saying that foreground service with type location requires the following permissions. Okay, so we have the foreground service location permission defined in the manifest. However, we do not have the actual runtime permissions to access location. So now what we have to do is, before we can start the foreground service, we need to actually ask the user for the runtime permissions. If the user grants them permissions to access location, then we can actually start the foreground service. If they don't, then we cannot start it because we will get the previous exception. This has changed with Android 14. Before, you could start the service and then actually request the permissions when you needed to access the location, but now you cannot actually start the service before you get the permissions. Okay, so yeah, we do this. It's also a good idea to check for the permissions inside the service before you call start foreground. And if the permission is not granted, then you can just stop the service because you will receive an exception either way. What some developers also do is you can wrap the start foreground call in a try-catch, and that will catch the exceptions, but it won't actually help you because it won't be a foreground service. It will just run as a background service. Cool. Okay, so now again, we can start the service again, and this time it will work because we fulfilled all of the requirements that are needed to start the service. Okay, so our service is running now. We can, if we're using locations, so we can gather updates and then post them or send them. But how do we actually stop the service? Well, we can call stop foreground, and that will remove the service from the foreground state, but it will not actually stop the service itself. To stop, and this stop foreground function accepts a flag called notification behavior, and what this defines is basically when the notification will be dismissed. So we can pass in remove, in which case the notification will be removed immediately when this function is called. We can pass in detach, and in this case, the notification will stay visible even after the service is entirely stopped. And then there's legacy, which means that the notification will remain visible until the service is stopped. And then finally, we can stop the whole service using the stop self function. Cool. Okay, so the other way that we talked about is using a work manager. So work manager has a built-in support for long-running workers. And it actually manages and runs a foreground service on your behalf in the background. Because Work Manager can provide a signal to the operating system, it can run this kind of workers for longer periods of time. So it behaves similar to a foreground service, right? And the examples for your use cases are you can do uploading, downloading, you can run local ML models, and so on. So basically, pretty similar use cases to like regular foreground services. And because it's using a foreground service, the same rules apply. So you still need to declare a foreground service type, and you need to fulfill all of the prerequisites, meaning the runtime permissions and so on. And how you actually create this kind of worker is you create a regular worker. So for example, a coroutine worker, and then you call set foreground. And if you use a coroutine worker, then it's already happening on the background thread, right? So you don't have to use some other framework like with the service. Cool. The difference is that the work manager already defines a system foreground service in its library, but you still need to declare it in your manifest. And you also need to declare the foreground service type. So if your worker is going to use location, you need to define a location type. The important thing here is also the last node merge property. And this basically tells it to combine this definition with the one in the work manager library. And this is needed because otherwise it will override it or it will get removed. Then, just like with the foreground services, you need to define the permissions. And again, because we're using location, we also need to define the location permissions. And also then later request them at runtime before starting the worker. Okay, so now if we take a look at the worker, we can see that this is a coroutine worker. But what we do is in the do work suspend function, we call set foreground. And this set foreground function accepts a foreground info object. And this should be like the first function that you call in do work if you want to have a long running worker. Okay, so now if we take a look at the foreground info object, we'll see that it looks really similar to the start foreground function in the service, right? So it accepts a notification ID, it accepts a notification object, and it accepts a notification, a foreground service type. So we basically have to pass in the foreground service type. Again, if we do not pass it, we'll receive the kind of exceptions that we saw before with the service. And then finally, you can create a work request and enqueue it. Also here, you should only enqueue it after you verify that the runtime permissions and the other prerequisites are fulfilled. Cool. Okay, so yeah, what to watch out for? It's similar to a service, so you need to declare your foreground service types. You need to check for the required runtime permissions before you enqueue the work. You should only use this when the work is important to the user and needs to run immediately and not be interrupted. Otherwise, you should just use the regular worker from Work Manager. While this is like simpler to use in a way than a service, you still need to do a place store declaration because you're using a foreground service behind the scenes. So still need to declare that this is a valid use case. Cool. Okay, so you have all of this done. Is there anything that you should know about foreground services? Yes. So there are background restrictions. So in most cases, you can only start a foreground service while your app is active. So like as a result of a direct user action by pressing on a button or doing some action. With Android 12 and newer, you cannot start a foreground service from the background, except in like a few cases. So one is if an app has a visible window or there's an activity in the backstack. If user interacts with an element of your app, like a notification, a widget, or like a bubble, if the app receives a high priority message from Firebase, if your app schedules an exact alarm and then triggers it, then you can start the service. Or if your app receives a boot completed action in a broadcast receiver that you declared. However, there's an asterisk there because with Android 15, this is again changing a bit. So you cannot start a foreground service from a broadcast receiver for types camera, microphone, phone call, data sync, media projection, and microphone. So basically, there's a few foreground service types left that you can actually start. Cool. And there are some other exceptions that you can check at the official documentation. One thing is that if you have a service of type camera, location, or microphone, these permissions to access this are actually while in use permissions, meaning that they are only granted to your app while it's open. And this means that you cannot start a foreground service of these types from the background because the permissions are only granted when your app is in the foreground. If you try to launch this kind of service from the background, in previous versions before Android 14, the foreground service will actually launch, but it will then result in an exception when you call, when you try to actually use like the camera or location or microphone. With Android 14, you will get an exception immediately when you create the foreground service. So the recommendation is to only launch it while you have a visible activity. Okay, so yeah, to summarize, Android 14 brought a lot of changes that related to foreground services that you need to incorporate if you want to target Android 14. I think, not sure when the official deadline is, but I saw somewhere that it's in August this year, that all new updates will need to target Android 14, which means that if your app uses foreground services, you will need to do all of this to be able to post an update. You can start a foreground service by either defining your service or using Work Manager. you have to declare foreground service types and fulfill runtime prerequisites before you can start the service. And really important is you will have to fill out the Play Store declaration and explain why you're using a foreground service. And then the reviewers will determine if this is actually a valid use case. If it's not, then most likely the app update will be rejected and you will need to use either the alternative APIs or some other approach. So yeah, the recommendation is still that if you're building a new app and you're thinking of using a foreground service, try to use any of the alternative APIs instead. Because based on history, there are more and more restrictions related to foreground services, and it's most likely to continue because I guess Google does not want developers to do work in the background. So if you are interested more in the code, I have a sample app available that you can check out. And what it does is it shows how to start a foreground service of type location from the UI, how you can request all of the runtime permissions that you need to start the service, make sure that everything is fulfilled. It also shows how you can bind to the foreground service to receive updates and then display them in the UI. It shows how to stop the service from the UI, and also it shows how to use the work manager to launch a foreground service. There's an asterisk there because I have not yet published the update, but we'll do it soon. So if you check it out today, it won't yet be there. Cool. And yeah, that's it. Hope you will now be ready to use foreground services.